Hello everyone, this is Javad and this is my first Capstone project for DataTalent Program in cohort 17. As for this project, I analyzed global air quality and climate from 1990 to 2020. So for this project, I analyzed the relationship between global air quality. For this project, I considered PM 2.5 concentration, and I saw the relationship between that one with climate variables like temperature, precipitation, and humidity. And also at the end, I designed an interactive dashboard for only global air quality from 1990 to 2020. So for this project, I use Python libraries like Panda, Seaborn, Matplotlib, and Bokeh in Visual Studio Code, and I designed the dashboard using Power BI. So at the first, I needed to clean the data and prepare data to be ready to analysis. So I integrated data from World Bank, and also I did some manipulation on that. In the next step for exploratory data analysis, I plotted distribution analysis. I saw the central tendency measures, and also I plotted time series trends and bivariate analysis. And at the end, to see statistically the relationship between those variables, I use heat map, and also I designed the dashboard for air quality. So for the data integration, actually, I did have four different data sets for the PM 2.5 concentration. As you can see here, these are the values for PM 2.5 for each country from 1990 to 2020. And also the structure for other datasets. For the climate dataset, actually it was the same. So for the temperature, precipitation, and relative humidity, the structure was the same. So we can see that we have a value for those variables by each month for each country from 1990 to 2020. So at first I needed to convert the dataset from wide to long format to have a consistent year-based alignment. So as you can see here, at first for the original dataset for the PM 2.5, we have columns for the years from 1990 to 2020 for PM 2.5. But here we can see that all of those columns are converted to one column, and those values also added to another column. And I also converted data type for the year to integer, and also I removed the values for the missing values for the PM 2.5 column because there were some null values over there as well. And in the next step for the climate dataset, I needed to sort values based on the year and country at the first, and then I needed to convert the year column to datetime, and then I needed to extract that year from the column. So we have one column which is year, and it only shows the year of that country and that aggregation for those variables. So and also after that I obtained the mean of temperature, precipitation, and humidity for each year. And at the end I merged those dataset into one dataset. At first I merged the climate data into one data frame, and then I combined with the PM 2.5 dataset to have a structured dataset there. So in the next step, I did EDA. For the EDA, at first I plotted the distribution of the variables. So I used Seaborn and Matplotlib in Python. And as we can see here, for the temperature and humidity, the skew of the values are to the right, and for the precipitation and PM 2.5 is to the left. And also we can see the central tendency of the variables here in this table for mean, median, and mode by using a simple code here. And also in the next step, I plotted time series trends and bivariate analysis by using a Bokeh to plot an interactive plot and figure. So for the time series trends, I use a line visualization, and for bivariate analysis, I use a scatter visualization to see the relationship between those variables. And as you can see here in this plot, by hovering over the line in the plot in the figures here, we can see the year and also its value for each variable. And in the bivariate analysis, we can see the relationship between PM 2.5 with other climate data set. And by hovering over the dots in the plot, we can see the values as well. But the thing is that here, if we want to confirm that there's a relationship between those values, we needed to statistically confirm that. So for that, I used heat map. I plotted heat map and the p-value map. I used Seaborn and Matplotlib for that, and I used dot heat map in Seaborn to plot those ones. So as you can see here, there are some relationship between PM 2.5 and precipitation, humidity, and temperature, as we can see here. So it means so this value means that if the value is closer to 1 or -1, there is a relationship between there is a higher relationship between those variables. And the positive value means that there is a direct relationship, and minus value means that, or negative value means that there is an indirect relationship. But we also needed to confirm these values by plotting p-value. So if the value is equal to or less than 0.05, it means that we can confirm that these values in the heat map are reliable. And as you can see here, all of or almost all of them are reliable over there. And also I designed a dashboard for the air quality analysis, and for this one I use average PM 2.5, and also I used average PM 2.5 year over year, its percentage change. So we can see that the countries with the highest and lowest average PM 2.5 here, and also the countries with the largest increase and decrease in a year over year PM 2.5. And also we can see that we can filter those things based on continent or subcontinent, country, and year. And there is a geographic map here that we can, by click on that, we can see, and there is a trend line here for the average PM 2.5. And I'm gonna do an interaction with the dashboard shortly here. Well, for the key insight, as I said, there were some relationship between PM 2.5 and climate dataset. And also for the air quality, we can see that in the developed country, we see a gradual improvement, but for the developing countries, there is a rising in PM 2.5 level. And those subcontinents which had the worst PM 2.5 value were belong to Northern Africa, South and East Asia. And we saw that there is no improvement in Africa's for the PM 2.5 year over year. So there is no positive change in the air quality over there. It needs attention. And also the interesting thing was that for Australia and Oceania continent, we saw that there is the air quality is good, it's like better than the average, but the trend is getting worse. So let me show you here in the Power BI. So this is the dashboard for the Australia. For example, if we click on that, we can see here that the average PM 2.5 is good, but since like in the last 3 decades, we can see that it's getting worse, and it's among the worst countries for the year over year PM 2.5. And also we can have an interactive with the dashboard. So we can see that for the Africa, for example, here we see the PM 2.5 values here, and also we can see those countries and their KPIs over there. And if we want to see the subcontinent, we can click on this, and we can see, for example, for the Southern Asia, we can see that there are like a very bad climate air quality over there. And also we can see for Canada as well, Here, if we go into the country filter, Canada. So yeah, so we can see here in the map as well, and we can see its trend over the year over year that it's better than the average, and also it has like air quality. So thank you for attention, and if you want to reach out to me, you can like contact with my email or in my LinkedIn, or you can see other project and also this project in GitHub, and also you can see my portfolio as well in my